For the 56th problem on the second ACT practice test, for x such that x is between 0 and pi divided by 2, the expression here is equivalent to what? So looking at this expression, what we can tell is that we'll have to use certain trigonometric identities. And probably the most important one to know is that if you have the sine function squared of some angle, which we'll just call x here, and you add to that the cosine squared of that same angle, then these two added together will always give you 1. So from this identity here, you can actually derive many other identities. For instance, if you divided everything by the sine squared of x, then what you'd be left with is 1 for this term, since you're dividing something by itself, and then plus the cosine squared of x over the sine squared of x, but cosine over sine is just the cotangent. So that would just be the cotangent squared of x, and then we'd have 1 divided by the sine squared of x, but 1 over the sine is just the cosecant. So this would just be the cosecant squared of x. And so this identity was derived by just dividing everything in this first one by the sine squared of x. But if we instead divided everything by the cosine squared of x, then what you'd be left with would be sine squared of x over cosine squared of x, and sine over cosine is the tangent. So that would give you the tangent squared of x, and then dividing cosine squared of x by itself would just give you 1, and 1 divided by the cosine squared of x would be the secant squared of x, since 1 over cosine is secant. And we have 1 over cosine squared of x. So that gives us the secant squared of x. So these are the three main Pythagorean identities. But like I said, if you just know this first one here, you can easily rederive these two here. But for this particular problem, we only really need this first one. And our clue that we're going to be using this is the numerator in each of these. So let's look at this identity and see if we can somehow get back either this numerator or this numerator. So I'll rewrite the identity. Sine squared of x plus cosine squared of x equals 1. And from here, I'll subtract cosine squared of x from each side. So we have sine squared of x equals 1 minus the cosine squared of x. So the reason I subtracted this cosine squared of x is that this new expression here looks fairly similar to this expression here. But the only difference is that square root. And since I have sine squared here, what I could do is just take a square root of each side. So then I just have the sine of x is equal to the square root of 1 minus the cosine squared of x. So now you can see that this numerator in the first term of this expression is this square root of 1 minus the cosine squared of x, but we just figured out that this is equal to the sine of x. So we can replace this numerator with just the sine of x. But going back to our original trigonometric identity, if we had instead subtracted sine squared of x, we would end up with this expression underneath the square root. So let's do that as well. So starting with this, we just subtract sine squared of x from each side. So on the left-hand side, we'd have the cosine squared of x, and on the right-hand side, this would be equal to 1 minus the sine squared of x, which, like I said, you can see this right-hand side is just equal to what's underneath the square root. And since we have the cosine squared of x, we can take a square root of each side, so that the cosine of x is equal to the square root of 1 minus the sine squared of x. And now this numerator here in the second term of our expression This, we know, is simply equal to the cosine of x. So now we know both of these numerators, and we can replace these complicated numerators with something much simpler. So let's rewrite the expression first, and then we'll substitute what we know. So let's replace this numerator here. We know the square root of 1 minus the cosine squared of x right here is just equal to the sine of x. So we'll replace this with the sine of x, and then this is divided by the sine of x. And then we'll add to this term here, but the square root of 1 minus the sine squared of x, we figured out up here, is just equal to the cosine of x. So we replace this numerator with the cosine of x, and now we divide by the cosine of x. And anything divided by itself is just equal to 1. So the sine of x over the sine of x is equal to 1, and the cosine of x divided by the cosine of x would be equal to 1 as well, and 1 plus 1 is just 2. So our final answer here is this letter H, 2.